Hi everyone and happy Friday. So today we're going to be working out of the packet that we started yesterday, and we're going to be using the last page of that packet. After we do the examples on this page, there's going to be a worksheet that the sub's going to hand out to you, and I need you guys to finish that by either the end of class or turn it into me first thing on Monday to get full credit. So we're going to start off by looking at the example at the top of the page, but we need to take a little bit of notes before we can tackle that example. So make sure that you have your packet ready to go. If you don't have this packet, if you lost it, there are extra copies on my desk under the blank worksheets. So for example 1 up here, we need to do the note-taking part. So we have to find the vertex of a quadratic formula in standard form. We know how to find it in vertex form, and it's really easy to find it in vertex form, hence the name. So remember, standard form is f of x equals ax squared plus bx plus c. A really important part to this is being able to identify our a, b, and c values. Now to find the h value of our vertex, which if you remember is the x value of our vertex, we're going to use the formula h equals negative b over 2a. So we're going to plug the b and a values from our standard form quadratic into this formula. Now if you remember, the h value is part of our axis of symmetry as well. The x value of our vertex is the axis of symmetry. So in example 1, we're going to test out using this equation. And we're going to find that x value of our vertex. So it says, what is the vertex of the graph of the function f of x equals x squared minus 8x plus 5? So first thing I'm going to do is I'm going to label my a, b, and c values of this quadratic in standard form. The x squared is going to have my a value, the negative 8x is my b value, the 5 is my c value. So a equals 1. Remember, if there's no number in front of the x, it's the same as a 1x. My b value is negative 8. And my c value is positive 5. We're not going to use the c value quite yet, but it's going to be important later when we're graphing these quadratics. So now I'm going to plug my a, b, and c value into that formula that I showed you. So h equals negative b over 2a. So for my b value, I'm going to plug in that negative 8. And for my a value, I'm going to plug in 1. All right, so if I have a negative 8, two negatives make a positive. So it's going to give me positive 8, and 2 times 1 is 2. 8 divided by 2 is 4. So my x value of my vertex is 4. That also means that 4 is my axis of symmetry. So now we have to figure out the k or y value of our vertex. And the way we're going to do this is by taking our h value and plugging it in for x in the original function. So anywhere you see an x in f of x, we're going to put a 4 in its place. So here we go. We've got y equals, and I'm just going to use blanks for my x values right now. All right, so y equals 4 squared minus 8 times 4 plus 5. 4 squared is 16. 8 times 4 is 32. And then we have our 5 on the end. So 16 minus 32 gives me negative 16. Plus 5 is negative 11. So my y value of my vertex is going to be negative 11. Remember from our conversation yesterday that the y value is also the minimum of my graph. So that's doubly important. So my vertex here is going to be 4, comma, negative 11. In example 2, we're going to find our vertex again, and this time we're going to use that information to graph our function. So first we find our h value of our vertex. So we're going to do negative b over 2a. My b value is negative 6, and my a value is 1. So negative 6 gives me a positive 6. 2 negatives make a positive. Over 2 times 1, which is 2. 6 divided by 2 is 3. So the x value of the vertex and my axis of symmetry is going to be positive 3. Now I have to find the y value by plugging that 3 in for my x in my original function. So I'm going to write out the function using parentheses. So remember our y value is the k value of our vertex. So I'm going to have the x squared minus 6x minus 1. In place of the x, I'm plugging in 3. So I'm going to have 3 squared minus 6 times 3 minus 1. 3 squared is 9. 6 times 3 is 18. Then minus 1. 9 minus 18 is negative 9. Minus 1 is negative 10. So the k, or y value, of my vertex is negative 1. This is also my minimum value for my quadratic function. So again, my axis of symmetry is going to be the x value of my vertex, which is 3. So that's x equals 3, a vertical line. And then my minimum, we can tell it's a minimum because our a value is positive, is going to be y equals the y value of my vertex, negative 10. There's one more value that I can find by looking at my function, and that is the y-intercept. And that value comes in handy when we're graphing as well. The y-intercept is always the c value of the function in standard form. So my y-intercept is going to be at the point where x equals 0 and y equals the c value, which again is negative 1. All right, so let's draw some axes onto our graph paper here. I'm just going to draw an x and y axis wherever. If you guys put yours in a slightly different spot, that's fine, as long as you can see the x and y axis on the graph when you're drawing it in. Now, to draw our vertex, we're going to go over 3 places to the right in the positive direction, and then we're going to go down 10 places in the negative direction. Once we have our vertex drawn, we can draw a vertical line straight through that for our axis of symmetry, which I'm drawing in red. And then we can draw a horizontal line through it, which is our minimum point, the lowest point that our graph can go. It can't go below that line. Now our y-intercept is always going to be on our y-axis, and we know that's at the point 0, negative 1. Now the axis of symmetry means that the other side of the graph is a mirror image of the first side. So we can use that to draw another point, basically in the same location as our y-intercept. Then we connect the y-intercept, the extra point, and our vertex to make our parabola. Now when you guys draw these, they don't have to be pretty, as long as they're as accurate as you can make them. Alright, so now we're going to try taking a look at another one of our imaginary classmates here. Guess we'll call that Yusin. Said that for the quadratic function, f of x equals 2x squared plus 3x plus 1, the vertex is at the point 0, 1. Is she correct? Explain. So you're going to need to use your vertex formula, h equals negative b over 2a, to find the correct vertex. Then you can use that work to back up why you think Yusin is correct or incorrect. I'm going to give you a few minutes to work on this. If you need more time, ask the sub to pause the video. Okay, this is another example that you're going to give a try on your own. We need to find the maximum height of the water balloon. This is an upside down parabola, so the maximum height is going to occur at the vertex. Which value of the vertex is going to talk about the height on this graph? It's the y value. You can see because my y-axis is labeled with the height. Now, the next part asks you the time it takes the water balloon to reach the maximum height. Which axis is talking about the time? When you figure out which axis goes with time, you can use that value from your vertex to help you figure out how much time it takes to reach the maximum. Once you figure out this example number 3 and the habits of mind that go with it, I'm going to have the substitute hand out your worksheet. And that's going to be more practice on these concepts that we went over today and a little bit yesterday. This worksheet is a reteach to build understanding sheet. This is just like the one that we did yesterday where we reviewed the information by filling in the blanks and making sure that we actually understand the work that we just did in the examples. I want you to do this whole side of the sheet. Try your best to fill in the problems. Talk to your classmates. The reason I set the desks up in pairs was so you guys can work together. So after you do this first side of the worksheet, you're going to flip it over to the back. And on the back, there is a little bit that I want you to cross out because it's some material that we're just not going to have time to get to in this unit. So at the very bottom of this page, there are some problems where it's asking you to find the function based on the points. We haven't gone over how to do that, so I don't expect you guys to work on this. So go ahead and just cross those problems out at the bottom of the page. The rest of this you should be able to do. It's called additional practice because it's more practice of what we've been working on. Remember, this work is due as a quiz grade, either at the end of class today or the beginning of class on Monday. I hope you guys have a great weekend, and I'll see you on Monday.